Also see here only one filter we are having at the beginning, and previously you have seen we have image reject filter, we have channel select filter. Image before mixer you will have image reject filter, after mixer you will have channel select filter. But see here, because I'm going to replace everything by a very high powerful band pass filter at the beginning and followed by LNA, I don't need all those channel selective filter is required at the first IF. Second IF, if required, now you can have a filter. Otherwise, even if it is not required for that, also see here some mild on-chip band pass filtering is usually inserted here to suppress out-of-band interference at this point, but it is not actually mandatory. You can have it or you need not have it. This IQ mixer will ensure that the other noises are going to be completely removed from your system. So next type of architecture is going to be sliding IF receivers. So we have seen basic heterodyne receiver, then we have seen double down conversion having two IF. And we had issues with image detection and channel selection. We went for 0 second order IF. So second IF alone, I'm going to make my IF frequency 0. So now one more type is sliding IF receivers. So sliding IF receivers, they work on the concept that, see, in double down conversion receivers, we had two LOs. But here, the sliding IF receivers, they are going to have only one local oscillator. This is because the design of oscillators and frequencies are becoming difficult nowadays. So we don't want to spend so much on oscillators inside our chip. So second LO frequency is obtained from the first by frequency division. It is also just like a double down conversion receiver only, but I'm going to use only one LO, and the frequency of second LO is got by frequency division. For example, if I'm going to take the first frequency and I'm going to divide by 2, it is going to be the second frequency of your LO. So for FLO1 by 2 will be FLO1 divided by 2 will be equal to FLO2. So I am going to use a divide by 2 circuit. So as depicted in the figure, certain divide by 2 topologies can produce quadrature output. So see here, LO1, directly for the first IF, I am going to use LO1. Then you are going to use divide by 2. And the divide by 2 is given to the two things, two mixers. So in phase will have one divide by 2 frequency. Quadrature phase will have one more divide by 2 frequency. Other things are going to be exactly same. The only thing, I'm going to take LO1 divide by 2 and I'm going to use that as the frequency for my in phase and quadrature phase components. Very simple. It is same as a double down conversion receiver, except that the first LO frequency and second LO frequencies are related. I'm going to use only one LO and I'm going to eliminate the need for second LO independently. So I'm going to divide the first LO by 2 and I'm going to use that as frequency for my second LO. So dividers, multipliers, divider circuits, we have log amplifiers, anti-log amplifiers. So division in logarithm becomes subtraction, right? So divide by 2 circuit can have any analog circuit which converts your frequency into half of the original frequency. So that can be done by any analog circuit.